Okay. You can see that there's two tables there for the ambient air temperature and ambient ground temperature being 4B2. On the next page, on page 395, we can see the tables. I think it's CC is not on that page. It is a couple of pages on. We've got the cables buried in the ground in section 5.1. Okay. If we're not using these factors, we use the multiplier of 1. Okay. Because it's very rare that a cable is going to be both run in the air and underground at the same time. Or we take the worst case scenario, whichever one has the highest factor that applies to it. CD is looking at the buried factor. So how far into the ground is it buried? Okay. CF was the one which I told you about, which was looking at whether or not the protective device is a fuse wire or not. Okay. So with the fuse wire one, so with a CF, as it's, are any of you likely to be designing circuits for fuse wire systems anymore? It's very doubtful because most of them don't actually meet the requirements for most of the regulations nowadays. So the likelihood of you ever having to use CF anymore is unlikely. So what factor would you be using instead for it?
1.
1. So if you multiply anything by 1, does it matter?
No.
No. So you can actually ignore these factors. Okay. We have CG, the grouping factor. Okay, and it's located in tables 4C1 to 4C6. That is taking into account different environments in which it's being run. Okay. CI is one of the ones which isn't actually located in Appendix 4. It's located in Part 5. Okay, and this takes into account the factor of how much depth the cable has been buried into thermal insulation and what effect that will have on our cables. Okay. CS is for the thermal resistivity of soil, because of course if you bury a cable in the ground, what's going to happen to that cable? Is it going to be able to vent its heat? No, it's going to start trapping the heat around the cable, isn't it? So we've got to take that into account because it will create more resistance. With more resistance means that the current carrying capacity of the cable is reduced to match it. Okay?
What's the minimum depth of this cable being installed in?
The technical line nowadays, depending on where it's run. Okay, if you look in the special locations, for some of the special locations, it can be anything from ½ metre onwards down. Okay, if the soil's likely to be turned over a lot, it has to be buried deeper. For any general place that you're burying cables, it's any sufficient depth that it won't be uncovered easily. Okay. So, if we look at an example here, we have a 6.5 kilowatt 230 volt shower to be wired in a domestic situation. Okay, it's going to be wired in thermoplastic insulation with flat sheath cables. Okay, it's going to be clipped direct to the ceiling joists over much of its length. Other than the similar cables in the roof, it's going to be grouped with one other circuit, and it's anticipated it will reach the ambient temperature of 35 degrees C in the summer. Okay. So, we're assuming that this system is on a TNS system. Okay, so what sort of key information for the designing can we start to pick out of this?
Power, voltage.
Yeah, we've got our power. What power have we got?
6.5.
So we know we've got power. .5 kilowatts. We know the voltage.
The ambient temperature.
Yeah, we've got an ambient temperature.
To 18 meters distance.
What was our ambient temperature first though?
35
35 degrees C. Okay, what was that you were saying?
I think the 18 meters, the run of the cable.
Yep, so circuit length.
It's gonna be installed on top of the joist, clip direct, yeah. It's fused already. And you know it's a twin and a, yeah?
Okay, will be clipped to the
Yeah, it's
side of the joist.
Clip to the side of the,
Clipped to the side of the joist, not on top of it. There's a massive difference. When it's clipped on top, it might not be in the insulation. But clipped on the side, it's going to be affected by the insulation massively.
to the side, yeah.
Okay? So we know it's clipped to the side of the joist.
It'll be grouped with another cable.
It's twin and a.
T and E. Okay. Well, anything else that brings up anything?
It's 18 meters away, no?
Temperature.
Oh, you got that.
So we're doing it with two examples, one being as a 3036,
Yeah.
okay, and one being as a BSEN 60898. Okay. So for the first one, we've got to include a correction factor of CF
Is that
0.725. Okay.
is that a plug top fuse?
Not a plug top fuse, it's fused wire.
Oh, the fuse wire, yeah.
3036 is a fused wire.
60898 is a circuit breaker.
60898 is circuit breaker. Plug top fuses are 1362s. Okay. So where do you think is the best place to start with this design?
The 6.5 kilowatt, the design current.
That's it. We start off with the design current, as it said on that list earlier, don't we? So if we start off there with that design current, if I do 6.5 kilowatts divided by our voltage, which was 230 volts, what's it going to equal?
28.26.
Was it 28.26? Okay. That's quick. I haven't even asked anyone for the answer yet. Okay, so what's our next step? Can you remember? Few sizings. If you remember, we have to satisfy we've got to satisfy that, haven't we? And it actually gives you the starting point for this. So we started off with the design current IB. We then go on to IN. So what size protective device would I be looking at for a 20 amp load, 28 amp load? 32 amp breaker. Okay. Okay. One
32 amp fuse wire, yeah? You're doing A.
It's fuse wire, isn't it? I can't
Yeah.
remember what fuse wire. It's 30 amp, isn't it? Fuse wire. Been a while since we had a fuse wire. Yes, 30 amps. Yeah, 30 amps. Okay. So we've got to pick out 30 amps for that. Apologies on that, as fuse wire isn't very common anymore. It's not one of the ones that we tend to design for. So, in my old age, I'll start to forget some of the stuff. Okay. So, where am I going to move to next with this? What do you think? So I've got to do something before I can select my cable, haven't I? Can you remember what it was?
You've got to work out the volt drop.
Before we even get there?
Method of installation.
What was that?
Rating factors.
Rating factors. So we've got a formula which is IN. of the other factors.
CG,
I've got CG on there. CF, CG. That's the one in the on-site guide, isn't it? That's the common one. Okay. So this is the bit that we've got to start looking at. So with looking at the factors that we've got, you've all hopefully got Appendix 4 still open in front of you. Which factor shall we start to look at first? You want to start looking at temperature.
Yeah.
So if we go to table 4B1, which is on page 394,